So basically, this is the APRA pH 60 that measures both pH and temperature. And if you have the correct probe, it'll also record ORP, which is oxidation reduction potential. And so what I'm going to do is get some of my reverse osmosis water here. Rinse. And I'm at about a half a cup, give or take. And this is my distilled water in the bigger container, measuring cup. So I will pour some water in that. That's distilled as the final rinse, if you will. Okay. And you're going to want to take the cap off, and this has already been pre-calibrated. I did this yesterday, so it's ready to go. And I'm just going to hit the power button once. You'll see it lights up, and it's ready for testing. Okay, so I'm going to go ahead and swirl that around to get rid of any bubbles that might have occurred, like when you dive into the deep end of the pool. And we're going to let that calibrate. Sorry, we're going to let it measure. It's already been calibrated. And actually, while we're waiting, it calibrates with 3 different types of solutions. There's a 4.0 solution, a 7.0, and a 10.01. And I was able to successfully calibrate all of these, and it shows up on the digital display as LMH, or low, medium, and high, which means it will actually record all the way down to 0, which is the lowest pH possible, very acidic, all the way up to 14, which is very caustic, very high alkaline. So that's what it's done. And when you see LMH, you know that you're calibrated and it's ready to go. Now, what we're waiting for this to do is actually create a stable reading, which will still flux a little bit, but by hundredths, not by tenths or 1%. And it does that by showing a smiley face. So we like doing that because we don't like seeing skewed results. And I'll give you an example of what I deem a skewed result. On this camera, you will actually see a different type of test, but nonetheless, it's using a test strip, and the color doesn't even match the full spectrum. Either there was something wrong with the printing label on the bottle itself, or the test strips are expired. It didn't show that for me, so then I assumed that it's probably the printer. But this grayish brown is not one of these samples, and so it renders this entire hardness of testing for hard water useless to me. So I don't care if it's $6 or $12, it's a waste of money. So this is why I live in the digital world, to bring you to a product that is, for me, it was $79 on Amazon, and it has 4 different probes that you can put on it, including ORP, which is oxidation reduction potential, which just tells you how much more pure the water is and how much oxygen is in it. And the lower or the higher in negative voltage readings, like negative 100 is pretty good, but negative 500 is even better. For you that understand algebra, that is less corrosive, and it's actually better for the body. Now, it just depends on which side of the church pews you sit in, but from my standpoint, I've had very good water and cut back drastically on things like sodas and acidic fruit drinks. Partially because they're real sugary to begin with, because they're trying to offset the acidity. Ever eaten a non-maraschino cherry straight off of the tree after washing it? It is not sweet at all. it might as well be a lemon. So, but the other reason why is because, the body just doesn't like it. That's why if you drink sodas or any kind of seltzer water or carbonated water, it just goes right through you. Ever notice that? You can get the big quart size or gallon size drink of pop at the theater, but your bladder's going to burst drinking that, and you're not going to make it through the movie without an interruption in most cases, unless you just don't drink water to begin with, and then maybe your kidneys need to be flushed out with quality water. Okay, so one of the things that the instruction manual recommends that if you're going to use this for water treatment, particularly with reverse osmosis water, also commonly known as RO water, you need to give up to about 5 minutes for that reading to stabilize, just to make sure that it's giving you a good reading. Okay, so I'm taking a look here, and it's still kind of fluxing around a little bit. Go figure. So I don't have my smiley face. It looked like it just touched it. It gave a kiss, and then it ran. That's what we call a kiss and run. So it's lobbing around. It almost seems erratic. So I'm going to give it another swirl. This usually is indicative of having some sort of air bubble on the bulb. So we'll stir it around gently and then set it back down, see if we can get this to settle down in its reading. And there we go. I got a smiley face, and I don't know if you can see that on this camera, but we got a 9.81, which is a correct reading because I can actually get close to, if not touching 10.0, which is perfectly safe for human consumption. And it's actually very good in terms of oxidation reduction potential. So to give you an example, 0 millivolts rides right at 7.0. And then as you increase in your pH, it increases the negative millivolt reading as well. So when I get into high 9s and low 10s, it's perfectly fine. You really don't have anything to worry about until you start hitting into 12s, 13s, and Lord, hopefully you never see a 14 in your water. It's just too much. Now, why is pH important? Well, if you're in a municipality that has a water treatment facility, they actually put things in the water so that it will cause a leaching, if you will. It actually you'll see some corrosion on copper pipes, on the internal pipes. That is by design, believe it or not, and it actually elevates the ability to help offset bacteria from being promoted in the water. So that's why people like copper pipes. But you may live in an area that just absolutely says, nope, we're not going to have copper pipes. You have to have CPVC pipe or PEX pipe, because they know that something that says it's lead free and the fittings, when you start connecting plumbing, it's not 100% lead free. It's 0.025. So there's a trace amount of lead because it's just easier to form these fittings when they're in the foundries, pressing these components, building them, pouring things in to mix with brass and zinc is it copper and zinc to make brass fittings. Okay, so that's what's going on with that. Oh, hey, by the way, after a while, that reading auto shuts off. So I'm going to take it out of the RO water. And there was a bubble in it. That's why I was getting erratic swings from as low as 6 or high 5s all the way up to the 9s range. So that usually means you need to stir it some more. And then it finally did it. They also say that if it's still after stirring, just to kind of shake it off, so to speak, and then go in there, and then you shouldn't have that bubble where it was before. It's going to be gone. Okay, but I'm going to stir this in the distilled water to basically offset what was in the RO water. Okay, and you know what? I'm going to keep that RO water because we're going to use it for other testing. So I'm just going to put 6 ounces off to the side there, and I'm going to actually get some tap water here. Remember that I have hot water recirculation in my plumbing. So this faucet came out warm, like in the mid 80s, and I just wanted to try to cool it off a little bit. It's not going to be ice cold, but I just don't want it to necessarily feel warm. It's just a personal preference. And I'm actually going to rinse that out and then give it a little bit more. And so I'm sitting right about 30 milliliters in this beaker. Okay, so you can kind of see, not a lot. And that's because we don't want the water level to get higher than this orange-red rubber seal that's around this, because that's where the electronics, north of that, you start messing up the entire thing. So I'm going to turn this back on, a quick button release, and I'm going to set it in there, and I'm going to stir it around a little bit just to swirl it to get the bubbles off, and we're going to see what we get here. Now, because this is not reverse osmosis water, I'm thinking that we should get a pretty quick read on this, where reverse osmosis water is more stringent in its measurements. The cool thing about this APRA pH tester is it does have the ability to change out the probes for different things. They have a spear-shaped probe for testing soil, citrus, fruits, soil composition, so that you can make any soil amendments that might be required. Maybe you need it to be a little more acidic, maybe you need it to be a little more alkaline. So you might have humig, if I remember the proper soil amendment additive that I added to my lawn, and it's just got a bunch of nitrogen in it, and it chelates, so it's not dissolving right away. It's little black balls, and you put it and mix it with your fertilizer, and you prep the soil so that you can put like reseeding your lawn, for example, and it just sets the best environment from a pH standpoint and nutrition standpoint, so it doesn't burn the roots. It actually creates a very cohesive system for those seeds to germinate. They also make a probe for complexion and paper and fabrics, so that you can test for color fastness, or for photography and you're making a print, you want to make sure it's not too corrosive, especially if you're doing old school dark room film processing. Some people still do that, and then also, like I said, for the complexion. So maybe you need to switch the foundation that you use on your skin, or a topical cream that you're using for some sort of blemish. You would be able to periodically test the pH and see if you're where you and your doctor agree that you need to be. So it's pretty cool. I sure hope I'm not blurry. All right, so I'm taking a look back here, and it still looks like we're swinging all over the place. So I'm going to do the let's see if we can get a better read on this. And it looks like we're coming in. Yep. So the tap water is actually coming in at 7.83. So anything between 6 and 8 is going to be considered normal depending on where you live. So don't let those readings throw you off. So I'm just going to write down in my notes that I have tap, and it is 7.82, it looks like. All right, so it's time for me to upgrade my reverse osmosis. I know that I've been waiting to put the system together with the upgrades that I want to teach my students, and so this is a good baseline for where I'm at, and I know what the performance has been over the last couple of years, and it looks like it's definitely saying, hey, we're ready to start pulling into the pit stop and getting a new fresh set of tires. So that's it on this. And by the way, that was 80.8 degrees, and that was me cooling off my water. So it typically runs warm about 85 to 90 degrees, that heat recirculation year round, so that when you wash your hands, it's nice and warm. It's not scalding hot, but it's not ice cold either. So hopefully that helps you guys. I'm going to stop this recording now. Take care.